Hi guys, so we're going to start our industrial period videos now. Start off with germ theory, Pasteur, Robert Koch. Hopefully you guys, well you should all be very aware of these two individuals and this theory as it's dominant during this period. As usual, don't use these videos as your only basis of revision. Make sure you're using things like BBC Bite Size, Student Pod, Miss Ellison's emails. You need to be using it all. Okay. Right. Firstly, so the cause of disease in the 18th century, two ideas are dominating. Had dominated the explanations of the cause of disease during this period. Well, before this period, we go back to medieval and Renaissance. It's all about things like the four humours, miasma, etc. But four humours is really gone by now. By this point, it's not relevant in the industrial period. Neither is the idea that God is punishing you. Those two are completely kind of being dismissed. However, miasma is still kind of around as a belief. We know that from the cholera epidemic that we'll get onto during these run of videos. But miasma is a good one to be aware of if you get anything about a similarity between cause of disease from medieval all the way up to industrial. Okay, so just keep that in mind. Now, spontaneous generation, really important one to know for this period. It's a new theory. Right, and it kind of rises and falls in the same period. So spontaneous generation is only really relevant for industrial period. This was basically the idea that organisms were spontaneously generated by the process of decay in meat. So they just kind of just appear to cause the decay. This meant that rotting and decay caused germs rather than the other way around. Okay. However, as improvements in microscopes meant that scientists could see these microbes in the decaying matter. It's just a theory. A lot of scientists were unable to prove that spontaneous generation was correct. So it's just a theory, really, but it's the dominant one in this period, especially in Britain. Right. So Pasteur, he applies the theory of decay by microorganisms in beer to the cause of disease in humans. So Pasteur's stepping in. He's starting to challenge things like spontaneous generation. He believed if bacteria could cause beer to go bad, then that could make animals and humans ill. So it's really delving into the idea of germs, microbes. He looked at the French silk industry, was suffering because of disease attacking silkworms, so he identifies the bacteria which was causing this, and he's proving that bacteria could be killed by then heating a liquid in a flask that he'd sealed. So this is where we get the idea of pasteurization from. So pasteurized milk heated to kill harmful bacteria. So Pasteur's really developing this. Now in these slides I'm going to run through Pasteur's basically a lot of what Pasteur did. Again, you'll need to top up on it with your own revision. However, as usual, do pause the video and just take note of the different sections of Pasteur's kind of research. They are in chronological order, so don't be thinking about that. But they are key elements of what Pasteur did. So make sure you get this date. He publishes his results in 1861. So the discovery of germ theory is really linked to that date. Be careful of that, okay? Because like I've said before, sometimes the exam board can try and catch you out by putting a date at 1850, and that means they don't want you to talk about things like germ theory, okay? So really be aware of things like that. So he observes the unwanted microbes in wine and vinegar, which is turning them bad. So he's thinking, right, how is this happening? And he's really significant in proving that spontaneous generation is wrong, because decay didn't happen when it was sterilized. That was left when matter was left undisturbed. So he thinks, well, it can't just randomly appear if it's not affecting matter that has been sealed or kept separate, then spontaneous generation must be wrong. That's important, right? One of your key things with Pasteur, how he's disproving spontaneous generation. And he starts thinking about the idea as, decaying matter, it must also be linked to disease in the human body. If it's causing, whatever's causing the matter to decay, these microbes must be harmful for humans as well. And this is really the idea of germ theory. He then publishes Germ Theory of Infection in 1878, so it's just a more kind of advanced idea of what this is. Now, again, what he's finding is that for matter to decay, the microbes must be traveling through the air. So that's the distinction between spontaneous generation and germ theory. Spontaneous generation, that decaying matter decays and that causes germs, whereas germ theory is the other way around, that microbes are traveling through the air to land on the matter and they cause decay. Okay, now it doesn't really take off in this country. He's not a doctor, so his work was focused on decaying spoiled food, not disease. So doctors in this country didn't really give it much credit. And spontaneous generation was the dominant theory, and importantly, it was pushed forward by this man, Dr. Henry Bastien. He's one of the most powerful doctors in the country, and when you've got an expert like that pushing a particular theory, it makes it difficult for somebody like Louis Pasteur, Frenchman, and his ideas to really get hold in Britain. So Henry Bastien is one of the individuals that really prevents germ theory from initially taking off in Britain. Well, so what impact does germ theory have? Well, it encourages scientists to look for the link between microbes and disease. You've got people like Joseph Lister, so he reads Pasteur's germ theory and he links it to the surgical equipment and comes up with the idea of using something to sterilize equipment and stop that passing on of microbacteria to the surgical equipment, so you get antiseptics, carbolic acid, etc. Another guy who I doubt you'll be familiar with, John Tyndall. He's a scientist. He promotes the link between microbes and disease, so he's another one who really starts making that connection. A good one to note down, just he'll never be a paragraph on his own, but if you're looking at the impact of somebody like Pasteur, you can bring in John Tyndall and say, well, he furthered this by making that link between microbes and disease. So again, you've got this problem with Henry Bastien, who's still promoting spontaneous generation. So while Tyndall's ideas are quite important, again, it's the same way as Louis Pasteur. People aren't really listening to them in this country because Tyndall was not a doctor, he's a scientist. And same with Joseph Lister. His ideas are also doubted, primarily because couldn't prove why his theory worked. Right, so microbes can be seen because of the power of the microscope, but you couldn't identify what role they played. The doctors and scientists basically just knew there was a lot of microbes around and even in the body. So the stomach in somebody who's not ill would contain lots of microbes, and scientists were thinking, well, if that's the case, why aren't they ill? How can microbes cause disease if this individual has thousands or hundreds and thousands of microbes and they're not sick? So how can that work? So this evidence kind of limited Pasteur's theory the impact of his theory in Britain, because it was just that connection between germs and disease. Yes, we know now germ theory was correct, but at the time, especially probably about from 61 to about the 1880s, there wasn't much impact there because scientists struggled to prove how these germs specifically cause disease, and people like Henry Bastien were still promoting spontaneous generation. Okay, Robert Koch, so hand in hand with Pasteur. Why was he significant? So there's a bit of a race actually between Pasteur and Robert Koch. They had this kind of whole nation rivalry. Those of you who know your history will be aware that France and Prussia, like a precursor state to Germany, had a recent war. So Robert Koch and Pasteur, there's a lot of rivalry between Germans and the French, and they were really trying to push the boundaries of this germ theory. Now, so what does Robert Koch do? Well, he identifies that different germs cause different diseases. It is so important, this one. He discovers the bacteria that cause tuberculosis. He discovers cholerae bacterium as well. He publishes ideas and these methods. And he continues to look. So he continues to these experiments to look for these different diseases that cause, different microbes that cause different diseases, growing them using agar jelly in a petri dish. Please make notes of his process. That's really good evidence to use. He just makes it so much easier to study bacteria under a microscope when he's separating them in this way. He also then colors them by staining them with industrial dyes to make them quite easier to see the distinction between one bacterium to another. And this really inspires other people. So over the next decades, they're going on to discover microbes responsible for other diseases like diphtheria, pneumonia, meningitis, the plague, tetanus. He receives the Nobel Prize. He's considered the father of bacteriology. He's so important. And do think about when you're studying these individuals in isolation, do think about their impact over other great men or great figures of the period, because the strongest judgment answers come from those who can make that distinction between the very good scientists and the ones who had that ultimate impact. So be aware of that. And again, just a bit of a summary of what Robert Koch did. Please just have a quick look at this mini mind map and make notes. It nicely summarizes what Robert Koch is responsible for. Finally, I'm just going to summarize generally germ theory overall. So individuals, it's germ theory, it's all Robert Koch and Pasteur really. Yes, we can bring in Tyndall as well, so just have that in your back pocket, especially if you want the top marks. Really good one to look for. But Pasteur, Robert Koch, you can have a bit of Tyndall. Government, right, so again, just highlighting what I've talked about earlier in the video. The government didn't initially have much impact, and also remember, until the later period, they have this laissez-faire attitude. They don't get involved much in the everyday life of the people, so they just kind of have a backseat. They're not bothered by it. This really changes when more people start getting the vote, and government realizes it's important that they please people and get involved in their everyday lives. So we see that change later on this period. Again, I'll go over that in the Public Health Acts, but yeah, initially it didn't do much. Science, so new theories, strong desire to find new theories, improved communication, like the telegraph, railways. Don't underestimate those impacts. I know we talk about railways in American West, how that really pushes that migration development because the speed of travel. It works here as well. So when you're thinking about revision and you're doing one particular topic, think about how we have crossovers there. So the railways in the industrial period, it allows that quick, fast transportation of ideas, spreading messages, and scientists find it a lot easier to kind of communicate and share these ideas with one another. Technology, so the microscope is so important in this period. Like the power of the microscope to really see these microbes helps prove ideas, and the petri dish as well. Remember, Robert Koch, really useful for him to separate these microbes. And attitude. So a key term to note in this period is enlightenment, not too dissimilar to humanism, the Renaissance. Enlightenment where people should find rational explanations. So it's a good one to use. It's a good one for you to bring into any question on progression. But also remember what I was saying about Britain and their attitudes to germ theory initially. and it took a while for it to be accepted. It wasn't really till the 1880s. So think about those short-term, long-term impacts. Okay, you can still use it in the same period, but just be aware when you are explaining an answer to a question, you can say, well, it didn't initially take off, but however, by the 1880s, it was most dominant. And then certainly when you get into the modern period, germ theory is the dominant theory. So keep that in mind. Right, so there's a lot more you can do on germ theory. Please check out Student Pod. Please check out BBC Bite Size. So fantastic materials on there. Again, I want you to really think about in this period the influence, the impact of individuals. So you might get something about who had the biggest impact on understanding cause of disease. You could do a paragraph on Pasteur, a paragraph on Robert Koch, and in your judgment, I mean, if you're picking one of those, you can say, well, without Pasteur, you wouldn't even have the foundations. However, you'd also say, without Robert Koch, you wouldn't have, he helped prove people like Lister's theories. He helped prove people like John Snow's theories by finding the cholerae. So there's no right or wrong, but you need to be thinking about how you're forming those arguments before you go into the exam. All right. I'll see you on the next video.